Welcome to TechBrothersIT. In this video, we are going to learn about repartition in PySpark. Repartition reshuffles the data in a data frame to create a new number of partitions. It performs a full shuffle to evenly distribute data across multiple partitions. Now you can increase or decrease the number of partitions. Useful when you want to have balanced partitions for parallel processing or for writing the files. So here is our sample data, and we have 4 records. We have ID, name and age. Then these are the column list we have provided, and here we are creating a data frame called df, and df.show will show us the original data that we have right here. Now with the check number of partition before repartitioning, we can use get num partitions function. So df.rdd.get num partition will give us the partition numbers in this data frame, so in df data frame. Now if what we want to do, we want to increase the partition to maybe 8 or 10 or something. So depending upon this, let's say it return us 4, and then we can increase to maybe 8, or we can do that. Let's first I'm going to go ahead and actually run this, so we will go from there. First take a look exactly how many partitions we have. So here's my data, and we can see that ID, name and age, that's the data frame df we are printing, and the partitions there are 4 of them. So now what I want to do, instead of maybe I want to increase to the 8, so let's do and go to the 8 partition, and here I'm going to just rename to the 8, so we would remember that. And here also when we are printing, I want to make sure we have the correct name. So now we have a df partitioned _8, and we said df data frame repartition to the 8 partition, and here then we are printing the total number of partition in df repartition _8 by using a get num partition function. So if I will execute, and here I'm doing the same thing. I'm creating another data frame here, and then using the original data frame and repartitioning to the 2. So in this new data frame, we will have the 2 partition. So we can run this one and take a look from there. So let's execute, and in the first one we increase the partition to 8, and here we are decreasing the partition to 2. So you see that now it is given us the correct value. I could have actually in the print, I also have to put 8, but I forgot, but you can see the number here. So repartitioning is helping us to decrease or increase the number of partition. Now here repartition by column, if you want to do it. So here is the df partition by age, and then we have original data frame that we created by sample data, and I said repartition by 2, and then use the column age here. And then we are saying checking the partition here, it should return us 2 as well, and now so that should return us 2, see right there. And then finally we can see the results. So we can say df partitioned 2, and we will see, so it will show you the data. So think about that, it's not changing the data, it's decreasing or increasing the partitions. So when you are going to look into the data, it's going to be the same data, because we are not applying any filters here. We are just playing with the number of partitions in the data frame. So if I would have applied a filter and then some condition, that might increase or decrease the number of records, but here we are using the same data frame df and just playing with it and increasing the partition or decreasing the partition. That's what we are doing here. And why we are doing it? When you need a balanced partition for parallel processing, it is helpful. When you need to increase partition for better parallelism, or when writing large data to the avoid data skew and small files. So these are the different benefits of repartitioning. So you might end up in a situation where you will be using a repartition to increase the number of partition or decrease the number of partition in your data frame. I thank you very much for watching my video. Please subscribe my channel, and I will see you guys in the next video.